Hello everyone, I hope you're having a fantastic day today. We're going to be talking about a couple more identities here. Hopefully by this time you're getting to understand that all these identities that I'm giving you all come from pretty much one of the same places. And today is no exception. Your double angle identities are going to come off of the sum of two angles, which is what we actually did back on section 3-4. On section 3-4, if we have sine of 2a, for example, this would be the sine of a plus a. On section 3-4, we learned how to take the sine of a plus a and expand it to be sine of a cosine of a plus cosine of a sine of a, right? We learned to expand that back in section 4. So if the case happens to be that the angle is the same, right? Instead of a plus b, it's a plus a. Look at what happens here. We've got sine, cosine of the same angle plus sine, cosine of the same angle. So what's actually happening here is that we are adding, and we can actually combine this into being 2 sine a cosine a. We've got 1 plus 1 is 2. So for sine of 2a, if your a's happen to be the same like this, then we can simplify that and we can say that that is 2 sine a cosine a. Alright, that's just a way to simplify this trig function. Okay, now remember, these identities, I'm going to give them to you. So right now I'm just showing you where we got those identities. So this is going to be where they came from. Cosine of 2a. Okay, now this one, if it's 2a, it's cosine of a plus a. Remember, this is just where it came from. If you'll notice, there's actually 3 of them here. I'm going to show you how we got 3 different answers. Kind of like on section 3-1, when we took one of our Pythagorean identities, like sine squared plus cosine squared is 1. We're going to do the same thing here, where we start switching some terms around, plugging stuff in, seeing what happens. Okay? Let's do it. So cosine of a plus a is going to be cosine of a minus sine of a sine of a. So this is where the first one is going to come from here. Cosine of a times cosine of a, since they're the same, we can go ahead and combine that to cosine squared a minus sine squared a. Cosine squared a minus sine squared a. There's your first identity. Cosine of 2a is cosine squared a minus sine squared a. So that's number 1. Your second one would be, what happens if instead of cosine squared, what if we plug in 1 minus sine squared here? Right? So the second one here is going to be 1 minus sine squared of a, because that's what cosine squared is, right? We can substitute 1 minus sine squared for cosine squared minus sine squared a. Well, isn't that going to be 1 minus 2 sine squared a? And then the same thing, number 3, would be what happens if we take sine squared a and put in a minus cosine squared, 1 minus cosine squared a. So it's going to look something like this. We'll have cosine squared a minus, parentheses, 1 minus cosine squared, sorry. Cosine squared a. So if you look at this now, this will be a negative 1 and a positive cosine squared. So we'll have 2 cosine squared A minus 1. Alright, now the point I want to make here is that these are your identities. This is how we came up with them. So we used our addition of two angles, what we learned last time, our sum and difference rules, in this case both sum, and we just came up with new identities. These will always be the same. So we're going to use these identities along with everything else we've already learned, and we're going to come up with some pretty awesome stuff. Alright, so first, we are to rewrite using identities and simplify as much as possible. See that as much as possible right there? That's the key to this. You are simplifying to the absolute most that you possibly can. So here's what I would do first. Look at number 3. 2 sine of 45, cosine of 45, and look back up here. 2 sine of 45, cosine of 45. Does that fit any of these up here? Well, it fits this guy right here, doesn't it? Sine of 2a. So if it fits the sine of 2a, let me go ahead and bust this out here. This is going to be then, actually let me pull this down so you can see both of them at the same time. If it's this and I want to simplify it, it should be sine of 2 times 45 degrees. Because my a in this case is 45 degrees, 2 sine a cosine a. And that's sine of 2a. Wasn't that really just the sine of 90 degrees? 45 times 2. And the sine of 90 degrees is 1. So having these things handy is really a huge, huge help. It really is. Now, just so you actually see what's happening there, if we're given an angle, if we're actually given the degree or the radian measure, you could go back and do this. You know the sine of 45 is square root of 2 over 2. This is the square root of 2 over 2. Multiply 2 times the square root of 2 over 2 times the square root of 2 over 2 is 1. You end up with 4 over 4, which is 1. So you can actually see these do work out. All right. Number 4 here, 1 minus 2 sine squared of 25. 1 minus 2 sine squared of 25 is cosine 2a. Right? Cosine of 2 times 25. 2 times 25 is 50. Now I could go through and do an approximation on that if I wanted to with your calculator, and you could get what it's actually equal to. That's fine. I'm just going to leave it like this for right now, just for the sake of time. You can press buttons later. And then number 5 is 6 cosine squared x minus 3. Now this is the first time we're not actually dealing with something specifically on here. Let me do it like this. 6 cosine squared x minus 3. Well, this is where being clever comes into it a little bit. It's pretty close to this one, isn't it? Sine squared a minus something. The only difference is instead of 2 and 1, we have a 6 and 3. Well, I'm going to look at, to see if I can use this, I'm going to say, okay, is there any way that I can make 6 and 3 into 2 and 1 by pulling something out? And in this case, it's factoring out a 3. Here's what I mean. Down here, if I made this, let me get this where you can see it. If I pulled out a 3 from here, so that this would be 2 cosine squared x minus 1, I can do that, and that's okay, right? So what's this going to simplify down to then? Well, 2 cosine x minus 1 goes to cosine of 2a, which in this case is cosine of 2x. So that's going to simplify to be 3 cosine of 2x. Now, unfortunately, I can't go any farther than that because I have an x here and not an actual angle. Okay, so I'm not going to go any farther than that. All right, let's keep going. A lot of examples here. Good stuff. Number 8. Okay. Number 8 says 8, or excuse me, number 6. Number 6 says 8 sine x cosine x. Now this one's actually interesting because my formula is 2 sine a cosine a. Let me go back to the front here. This guy right here, 2 sine a cosine a, but in this case I've got an 8. So is there any way I could change 8 to a 2? Well, yeah. What if I factor out 4? 2 sine x cosine x. How about if I factor out a 4? Now the inside looks like sine of 2a. So that's going to be 4 times the sine of 2x. There's little things that you can do to help out with this. Really, it's just kind of a process of trial and error. Try something that works to simplify, and if it doesn't work, go back, try something else. Remember, anything inside of a box on this unit, you're going to have on the test. So you'll have these formulas on the test to use. Okay? Eventually, you'll memorize them just because you'll use them so much, but for right now, I'm not really worried about it. 7 says sine of 30 cosine of 30. See, now this one is different. This one is different because I need, like my formula set up here, I needed a 2. I don't have one up here, or I had an 8, so I divided by 4. In this case, I'm back to that same sine of a cosine of a. I need a 2. So I need this to be 2 and then sine of 30 cosine of 30. But you know as well as I do that I can't just plop a 2 in here and say that it's the same thing as it was before. Sine 30 cosine 30 isn't 2 times sine 30 cosine 30. This is double. So how do I compensate for this 2 that I just pulled out here? In a way here, what I'm doing in the problem before is I'm dividing out a 4, and that leaves me with a 2. Notice how if I multiply these back, I get 8. So what would I multiply with 2 to get 1? That's what you have to think about. What has to go here so that if I wanted to go backwards, I would get to here? I have to compensate for something here. So 2 times what gives you 1? Well, that'd be 1/2. 2 times 1/2 gives you 1. So what are you left with? You've got 1/2. Now 2 sine 30 cosine 30 goes to sine of 2 times 30. Which is going to be 1/2 sine of 60 degrees. Oh wait, I'm sorry, that's not a... I thought that was a 30 this whole time. That's a 3 theta. That's okay, it's an easy fix. You ready for this? Bam, 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 bam. And we'll just get rid of the degrees. We ain't worried about the degrees. I'm sorry, I was reading that as a 30, but it's not. It's 3 theta. That's my fault. I should have made that theta a little bit different, bold or something. That's okay though. Still works out the same. All right. Number 8, sine of 15 cosine of 15. So again here, just like in number 7, I do not have